Hello world, it's Calcutron here with the second episode in our series on TI Basic. In this episode, we will learn about variables, which are an essential element of all programming languages. One thing to note about this series is that the concepts we learn about here will also apply in almost any programming language you learn. So by following this tutorial series, you'll be very well prepared to learn exciting and useful programming languages like C++, Python, and Java. So, what are variables? You may have experience with variables from algebra, but in programming, they're a bit different. I like to think of variables as boxes where you can put numbers and then look inside the box to see what number it contains. In TI Basic, you have 26 boxes, which are represented by single letters. These variables, or boxes, can be accessed using the alpha key. So let's get started by putting a number into a box. If we want to put a number, we first have to say what number are we going to put. So let's do 5. And then to say we're going to store the number in the box, we go down to this stow key right above the on key. And that gives us this nifty little arrow. And then using our alpha key, we select the letter of the variable we want to store it in. So when we hit enter, 5 will be stored in A. So we've just put a number into the box A. And in order to get it back out, we can look at A. And we see A is equal to 5. So now, let's say we want to use A in an expression. Well, we can just put it right in there and say A plus 2. And it's going to say, I don't think I can add A and 2, but instead I'm going to look at A and find what is its value, and then add that value to 2. So it's going to come out with 7. And we can do this for any of the 26 variables A through Z. And we can then compose these variables in more complicated expressions. So we can do A divided by Z and see what happens. And we get a decimal. So you can also store decimals into variables and also negative numbers. So let's store 1.5 into X. Now X is 1.5. And we can use variables in expressions that we store in other variables. So we can do A plus 2 stored into B, and then we can do B plus 2 stored into C, and then we can even do C plus 2 stored into D, and we get a chain. And all the variables are 2 greater than the last one. And there's something you see a lot more often when you're using variables, and that is something called implicit multiplication. So you've probably seen an expression like 2x, where you would say 2 is the coefficient of x. And you don't see a multiplication sign, but it is implicit, which means it's implied that those two things are being multiplied. So when we hit 2x, we get 3, and remember x was 1.5. So that is correct, that is 2 times 1.5. But you don't necessarily have to put the coefficient, or the thing you're implicitly multiplying with x, first. So you can do x3, for example, and get 4.5. Or you can chain this together and you can get x3a, and you'll get x, which is 1.5, times 3 times a, which is 5, which is 22.5. So something, if you've worked in other programming languages, you might know that variables in more complex languages can be multiple characters long. So you can have a variable called apples. or you can have a variable called foo. But in TI Basic, all variables are one character long. So if you tried to do ABC as one variable, what it's going to do is implicitly multiply A, B, and C together. So there it multiplied 5 times 7 times 9 instead of having a variable ABC. And if you try to store to a variable with multiple characters, it'll tell you that that's a syntax error. So if we try to store to the variable ABC, we get a syntax error. So you'll notice everything we've been doing so far has been on the home screen, but this can apply not just on the home screen, but in programs. So if we hit the program button, let's go over here and create a new program, and we'll name it temp. And that does not stand for temporary, it stands for temperature. So we're going to use variables to convert easily between Celsius and Fahrenheit. So the first thing we should do is define what our variables mean. And this is really something we do in our heads. So I'm going to define that C stands for the temperature in Celsius, and F stands for the temperature in Fahrenheit. So we're going to start with the temperature in Fahrenheit, and then we're going to convert it to Celsius. So let's start with, I don't know, today it was pretty hot. Today it was around 85 degrees. So let's put that in to F. And now we're going to use F in an expression to find out what C is. So how do you convert Fahrenheit to Celsius? If I remember correctly, it's going to be F minus 32 times 9/5, or no, times 5/9. So you can see here I did something that was kind of tricky. We used implicit multiplication. So this expression, F minus 32, which is in parentheses, will be evaluated first, and then it's going to be implicitly multiplied by 5, and then that is going to be divided by 9. So we could also have put in a multiplication sign here, and that would make it more clear that what we're doing is a multiplication. And then we can go ahead and store that into C. So now what we have is our value of C, and if we go in here and go over to I/O, just like we did in the last episode, we want to display the result out to the user, otherwise it won't be very useful. So we're going to display this, and we're going to just put display C. So you might be thinking, well, this is just going to put the character C out to the home screen, but it's actually not. It's going to evaluate this C as a number, as a box that you can look in as a variable. If we wanted it to display C as a string, or put out the literal character C, we would have to put it inside of quotation marks. So that's the reason that we needed quotation marks in the last episode, that we couldn't have just done display hello world. Because what it's going to do is it's going to see, oh, you have a bunch of variables that you want to multiply together. So it's going to multiply H times E times L times L times O, and it's going to get really tripped up on this space and cause an error. So what you have to do is put it in quotation marks, or don't put it in quotation marks, and it will display the value of the variable. So if we second quit to exit this and then go to program temp and execute it, we get 29.44. So that's about 30 degrees Celsius, which is equivalent to 85 degrees Fahrenheit. One interesting thing is that variables exist both inside of our programs and outside of our programs. So before we ran this program, you might remember we stored 5 in A, and then we did A plus 2 stored in B, and B plus 2 stored in C. So before we ran the program, C was equal to 9. But now if we check what's in C, it's the same value as inside of our program. So C is equal to 29.4 repeating. And this can be useful, and we're going to take advantage of this when we're writing our temp program. So instead of inside of temp storing 85 into Fahrenheit, we're going to delete that line and then hit second quit to get back out. And we're going to have the user tell us how hot it is in Fahrenheit themselves. So let's say today it was a little colder and it was 70 degrees Fahrenheit. So we can do 70, stored in F. And now when we run temp, we get our new Celsius value for the Fahrenheit temperature of 70 degrees. So now we have a useful program to convert between Celsius and Fahrenheit, and I hope you learned a little bit about variables and how to use them in your programs and how to write more complicated expressions with them, as well as implicit multiplication. So don't forget about implicit multiplication. That's very important, and sometimes it comes up in mysterious bugs. So thank you for watching. If you have any questions, leave them down below. Bye-bye.